Okay, let's talk about the keyword extends and what it does to classes and prototypes. So here I have a basic class animals, name and age, and then dog is a new animal. And then here, console.log dog. Now, remember, placing summary right here outside the constructor makes it so that this method lives on animals prototype right here. So now what happens if I do class? Let's say we want to do flying animals now. Extends animal. What does this actually do? Well, this keyword makes JavaScript say, okay, whatever's on the right will be the prototype of whatever's on the left. So class animal is now the prototype of flying animal. What does this mean? This means whatever objects gets created by flying animal class can borrow methods and properties from its parent class animal. So if we try to construct a new flying animal, let's say we also want name and age, and we want a new argument, fly speed. So can I just copy this constructor and then just add fly speed, and then this dot fly speed is equal to fly speed, and then let's instantiate const hawk is equal to new flying animal, name doesn't matter, let's do 10 and 10. Okay, so we get must call super constructor and derived class, blah, blah, blah. What does this mean? Well, we used extends, so now animal is the parent class. The parent is already trying to construct two properties, name and age. JavaScript says if the parent's already doing that, the child cannot do that. So you have to delete this right here. So JavaScript wants whenever you create flying animals, you have to call super as a function, passing in name and age, so that flying animal knows to call its parent's constructor. Okay? So all this does is that whenever you create a new flying animal like hawk, JavaScript knows to call animals constructor to make the name and age, and it'll call flying animal constructor to get the fly speed. Okay? So now hawk, since it's created by flying animal, it has access to summary. And so can you do hawk dot summary? Yeah. Yeah. Now let's create something else here. Let's do a fly method, and let's just have this console.log what fly speed is, and then let's do this dot age plus fly speed, and then miles per hour. Okay, so now hawk should have access to fly, which is on its prototype, and also summary. So hawk.fly. Oh, it says fly speed. Is that fly speed? Oh, I forgot to keyword this. Don't forget that word. So then now you do hawk.fly. Okay, cool. But look, if you do dog, you cannot do dog.fly, right? Because dog was created by animal, and the parent class cannot borrow methods from its children class. Yeah. So that way you can never do dog.fly, and that's very useful. Okay? So it really does matter how you organize your parent classes and your child classes. Okay? Sometimes is it better to just include the fly speed in animal so you don't have to extend it, right? Sometimes it's better to extend it to compartmentalize everything if the animal has a lot of properties. Okay? So it's all depending on your preference. Okay, so one more way that we can use super is as an object. So let's say right here, instead of fly, what are we going to console.log? Let's just console.log super dot summary. Okay, and then now our hawk dot fly will return this summary. Okay, So all super does, if you follow it with a dot notation, is that it grabs the parent class animal, and then it grabs whatever method name that you put after the dot, in this case, summary. But you don't need to actually do this most of the time, right? Because fly, Hawk has access to fly, and Hawk, being instantiated by flying animal, will have access to all of its parents or its prototypes methods anyways. Okay? So you could just do Hawk dot summary like we did before, right? So you don't have to do Hawk dot super dot summary or something like that.